Imagine a beautiful day. You are strolling in your garden. Suddenly you step on something sharp. Ouch, it's a rusty nail. Tiny invaders, bacteria, have entered your body. What happens next is a remarkable story of your body's defense system, the immune system, springing into action. The moment the rusty nail breaks the skin, it creates a pathway for bacteria to enter. These microscopic invaders waste no time. They begin to multiply rapidly, hoping to make your body their new home. But your body has other plans. It has an intricate and powerful defense system in place, ready to fight off these intruders. Let's delve deeper into how this microscopic battle unfolds. The first line of defense against the invading bacteria is a type of white blood cell called a macrophage. These cells are crucial in maintaining the body's immunity and overall health. Macrophages are like the security guards of your body, patrolling your tissues and keeping an eye out for anything suspicious. They are always on the lookout for potential threats. When the bacteria enter through the puncture wound, they release chemicals that signal distress. These distress signals are like a cry for help that the macrophages can detect. Macrophages sense these signals and rush towards the site of the injury. Their movement is swift and purposeful, ensuring they reach the site as quickly as possible. Once they arrive, macrophages go to work immediately. They waste no time in identifying and targeting the invading bacteria. They have a remarkable ability to engulf and destroy bacteria through a process called phagocytosis. This process is essential for clearing infections and keeping the body healthy. Imagine a macrophage extending its long arm-like projections to capture a bacterium, pulling it inside and breaking it down into harmless pieces. This is how they neutralize the threat. Macrophages are not only efficient killers, but also excellent communicators. They play a key role in coordinating the body's immune response. They release signaling molecules called cytokines that alert other immune cells to the infection. This ensures a coordinated and effective response to eliminate the invading bacteria. As the battle against the bacteria rages on, a new wave of reinforcements arrives, the neutrophils. These cells are crucial in the body's defense mechanism. Neutrophils are another type of white blood cell and are the most abundant type in our blood. They make up about 50 to 70% of all white blood cells. When macrophages sense an overwhelming infection, they release cytokines that act like a distress signal and alerting the body to the threat. These signals travel through the bloodstream and reach the bone marrow, where neutrophils are produced in large quantities. Upon receiving the signal, the bone marrow releases a large number of neutrophils into the bloodstream, ready to join the fight and combat the infection. Neutrophils are particularly adept at killing bacteria with enzymes and reactive oxygen species, making them highly effective in neutralizing pathogens. However, the battle against infection comes at a cost, often resulting in inflammation and pus formation at the site of an infection, as the body works to heal itself. While macrophages and neutrophils are busy fighting the bacteria at the front lines, another type of immune cell plays a crucial role in shaping the long-term immune response: the dendritic cell. Dendritic cells act as the intelligence officers of the immune system. They capture invading pathogens like the bacteria from the rusty nail and break them down into smaller pieces called antigens. Once they have captured and processed the bacterial antigens, dendritic cells migrate to nearby lymph nodes. Inside the lymph nodes, dendritic cells present the captured bacterial antigens to other immune cells, specifically a type of white blood cell called a T cell. Inside the lymph node, the dendritic cells present the bacterial antigens to helper T cells, initiating a crucial step in the immune response. Helper T cells are like the generals of the immune system, orchestrating the defense strategy against invaders. When a helper T cell encounters a dendritic cell presenting an antigen that matches its receptors, it becomes activated, ready to lead the charge. Activated helper T cells multiply rapidly, creating an army of clones, each prepared to fight the infection. Some helper T cells activate B cells, which produce antibodies, the body's targeted weapons against pathogens. Antibodies bind to specific antigens, marking them for destruction by other immune cells, ensuring precise targeting. Other helper T cells activate killer T cells, which are specialized in identifying and killing infected cells, preventing the spread of the infection. As the immune response progresses, the combined efforts of immune cells effectively control and eliminate the bacterial infection, restoring health. The site of infection begins to heal and inflammation subsides, marking the end of the battle. The immune system remembers past infections, providing long-lasting immunity to certain diseases, ensuring quicker responses in future encounters.